Today, we'll be presenting an overview and analysis of Security Technical Implementation Guides, or STIGs. Our team, Prathama, Emily, Luca, and myself, Ben, work together to break down what STIGs are, why they're important, and how they help strengthen system security, especially in environments like Oracle Linux.
The first thing we're going to talk about is SSH configuration. This one has a high severity level and it requires that the operating system must not allow direct root login through SSH. The idea is to enforce least privilege. Users have to log in with their personal accounts first and then escalate access only if needed. This helps reduce the risk of unauthorized system-wide access and makes actions traceable to individual users. A real-life example of why this matters is the 2017 WannaCry ransomware attack. Compromised root logins made the attack spread faster. Blocking root SSH logins could have helped stop it. To start implementing this STIG, you have to open the SSH configuration file using the sudo command. Once you're inside the file, you have to look at the specific line that controls root login, and it's called permit root login. Once you find the correct line, you have to remove the command symbol and you have to change the value from prohibit password to no. This setting fully disables root access with SSH, strengthening the security posture of the system. After making the change, you have to save the file by pressing escape and typing :wq and then hitting enter. You have to also restart the SSH service using the sudo command sudo systemctl restart sshd to make sure the new configuration would take effect. Finally, you have to verify the change by running the command grep permit root login space / etc / ssh / sshd underscore config. This allows me to confirm that the root login setting has been properly updated as required by the STIG. Overall, implementing the STIG really emphasized how important it is to secure remote access. Disabling root login over SSH follows best practices like enforcing least privilege and improving accountability through the use of individual user accounts and sudo. Even though it's just a small configuration change, it can make a huge difference in reducing risk and improving system auditability. This test showed how even a minor adjustment can contribute to a much stronger and more secure operating environment. Now I'm going to hand it over to Emily to explain the next step.
The second STIG we will be covering enforces signature verification for local packages in Oracle Linux 8. The vulnerability risk for this STIG is high, so implementing it will prove to be a powerful tool to protect sensitive data. You may be wondering why you would want to enforce signature verification. By enforcing signature verification, you are ensuring the integrity and authenticity of all software components by only allowing packages signed by an approved certificate authority, preventing tampering of data, supply chain attacks, installation of malicious software, and self-signed certificates. An example of when this STIG could have prevented a cyber attack is the 2020 SolarWinds breach, where the software company suffered from a group of hackers bypassing package signing and planting malicious code into the company's software update, which allowed the hackers access to customers' networks, including government agencies and private companies. To implement the STIG, you will want to work on Oracle Linux version 8 or higher. Once you have signed in, click on the Activities button located in the upper left-hand corner, then Open Terminal, which will look like the icon shown on screen. Once you are in Terminal, type the sudo command shown on screen and press Enter. Terminal will then ask you to input your password. After that, look for the line local pkg underscore gpg check equals true. If it is not already there, press I to insert the line yourself. If you inserted the line, make sure it looks like the example on screen. If the line was already present, make sure it is equal to true, and change it if it was equal to false. To exit, press escape and type :WQ, then enter. If you want to make sure the STIG is implemented, you can run the command presented on screen, which will return the appropriate line if the implementation was successful. This STIG is important because of its many security features restricting malicious packets, software, and certificates, preventing hackers and viruses, and limiting actions of unauthorized users. Now I will hand it off to Luca to present our third STIG on account lockout policy.
Third STIG we will be taking a look at is the account lockout policy STIG with the finding ID of V-248659. It's a medium severity STIG, so it could end up harming you if it's not implemented, but not necessarily a massive breach issue. Oracle Linux 8 must make it to not let people attempt too many logins, which leads to the overview of the STIG, which is just limiting the number of failed login attempts. Like an iPhone, you only get so many chances to type in your password before it locks you out. It is basically like that. This STIG is good at limiting or completely stopping brute force attacks, automated login attempts, and account surfing, which is basically getting user information about someone from one site and trying that information on other sites to see if they can access more data about yourself. A real-life example when the STIG could have been proven useful was a cyber attack against the bank JP Morgan Chase in 2014. Cybercriminals used a few different methods, including brute force attacks, which ended up compromising over 76 million homes and around 7 million businesses. Having no lockout policy was not only the main issue in the attack, but it was definitely a weakness that could no longer be ignored. To implement this STIG, you will first want to open the command prompt and type in this line right here. This will open up a text file. After you type in that and the text file is opened, you'll want to add this line right here, the dear line boxed in the red, and you don't want it commented out. So make sure to get rid of the number symbol. After you do that, you can exit the text file and type in this command boxed in the red. This will make a directory to capture failed logins. Then you want to type both of these lines boxed in right here. After doing that, you'll want to go back to the command prompt and type in this line right here, and it will open a text file. Then over the auth section, you'll want to add these two lines right here, and over the account section, you'll want to add this line right here. These are basically the different policies for your lockout. After you do so, you will want to do it again basically, but in a different text file, the password auth file, which is the steps are very similar to the last two. Then you'll want to add these three lines as so. To check and make sure they were implemented correctly, type in both of these lines right here, and you should see fail lock pop up for both of them. Now, every time someone tries to log on and fails, it will be tracked and will time them out after too many attempts. As we wrap up this STIG, implementing it clearly has its importance. Being able to track failed login attempts allows for nothing to go unnoticed, which helps improve the security integrity. The lockout function is also crucial, so someone doesn't get unlimited attempts at the database. This STIG is a moderate level STIG, so it doesn't have to be implemented, but it really should if one is worried about brute force attacks. This demonstration showed you how you can protect your software from unwanted guests and have a list of those people for future reference. Now I'm going to pass it on to Ben, and he'll finish us off.
The fourth STIG we will be covering focuses on unrestricted access in Oracle Linux 8 systems. This STIG requires that only the root account is assigned a UID of 0. That's because UID 0 gives full root level privileges. If any other account is assigned UID 0, whether by accident or for testing, it creates a major security risk. The overview highlights the dangers of this. If another account is UID 0, it can essentially act as root without triggering root login alerts, bypassing normal security measures. To stay compliant, we need to regularly check the -etc-passwd file and make sure no account besides root has UID 0. A real-world example of why this matters is the 2019 Capital One data breach. In that case, a developer account was accidentally given UID 0 for testing. It was never removed, got compromised in a phishing attack, and the attacker gained root-level access without being detected. So the takeaway here is restrict UID 0 to the root account only, and audit your systems often to catch any violations early. To implement the STIG, we start by reviewing the -etc-passwd file. This file stores all local users and their UID values. Our task is to ensure only the root user is listed with UID 0. This command uses AWK to filter -etc-passwd and find any users with UID 0. The expected result should only show root. If any other names appear, that's a finding and needs to be rectified. When we ran the UID 0 audit using AWK, the only result we got back was root. That's exactly what we want to see. It means no other users on the system are assigned UID 0, so no unauthorized accounts have unrestricted access. This confirms our system is currently compliant with STIG V-248874. It's a simple check, but a really important one, and it should be done regularly or scripted into system audits. If any account besides root has UID 0, we need to fix it immediately. If the account is used for system functions, assign a UID between 1 and 999. If it's a regular user, give it a UID above 1,000 that isn't already in use. After changing the UID, you also need to change the ownership for anything that user previously owned. This prevents permission issues and maintains access integrity. The sudo part in the command runs the command with super user privileges required for user modifications. The user mod is a tool to modify user account properties. -U990 changes the UID of the account to 990. user, the username whose UID is being changed. Implementing the STIG reinforced the critical importance of controlling privileged access by ensuring only the root account holds UID 0. This aligns with the principle of least privilege and is essential in minimizing the risk of unauthorized root-level access. The task highlighted how misconfigured UIDs can lead to serious vulnerabilities, including bypassing standard monitoring and alerts. By auditing the -etc-passwd file and validating that only the root user has UID 0, we can strengthen system accountability and enforce proper access boundaries. The use of command line tools like AWK and user mod to detect and correct issues demonstrated how small configuration checks can have a significant impact on security posture. This exercise emphasized that even simple UID audits, if done regularly, can greatly improve system integrity and help maintain a secure, compliant environment. As we conclude, here's a look at the sources we used throughout this project. These articles and reports helped us connect real-world cybersecurity incidents to the STIGs we analyzed. They show how important it is to enforce strong security standards like the ones we discussed.